A magnet is one of those things that nearly all of us have used and yet have no idea how it works. Most people could tell you that a magnet exerts an invisible force on other magnets, but not many people could tell you why. Actually, scientists are still theorizing about the exact cause of magnetism. But has that ever stopped you from sticking papers to your fridge? Without stepping into the esoteric world of quantum mechanics, we'll look at the root cause of magnetism and then talk about some of the fundamental properties of magnets. Although magnets were first discovered over 2,500 years ago, it wasn't until the 19th century that scientists learned that moving electrons are responsible for magnetic force fields. Why moving electrons do this is a very complicated theory, but for our purposes, it's enough just to know that this is what happens. Since atoms are surrounded by moving electrons, many will act like little bar magnets with a north and a south pole. In materials where the atoms are naturally aligned, the individual atomic magnetic fields unify to create one big magnetic field. Objects that always exhibit a unified magnetic field are called permanent magnets. In many materials, such as iron, the atoms are naturally disorganized and don't create a unified magnetic field on their own. However, when a magnet is placed nearby, the atoms in the material respond by rotating into alignment, temporarily turning the object into another magnet. When this happens, we say that the object has been magnetized. In most materials, the atoms return to their original positions once the magnet is removed and the object becomes demagnetized. This is why things like paper clips don't act like magnets on their own, but do behave like magnets in the presence of other magnetic objects. Depending on the material and the strength of the magnetic field, some objects will remain magnetic even after the other magnet is removed. This is a handy trick for getting small screws to stick to the end of a screwdriver. An easy thing to take for granted about magnets is that they always have a north pole and a south pole. Magnets are called dipoles, which literally means two poles. If you could cut one end off the magnet and have just a north pole, then this single pole would be called a monopole. However, no one has ever been able to do this. It turns out that every time you cut a magnet, you end up with a north pole and a south pole on each piece. Even if you could cut the magnet down to the size of just one atom, which would be really difficult, the atom would still have a north and a south pole.